If I promise to do a short presentation, I will do a short presentation.
You have time.
Well, I promise to do short and okay, there are some
So no
people not
slides.
happy because we are late. So let me remember my PowerPoint. It's about resilience of network. And the idea is to say, okay, maybe because of incident, because of climate change, or because of major shock, the transportation network, and I am looking automobile, transportation may be affected. And what happened then? Okay, and can we have a study rather systematic? Because what is interesting is not only do one network, but to look several networks and compare this network. Now, there is some research in mathematics about this problem. Okay. I don't understand everything, but they say percolation when you have a little shock and then suddenly you cannot go from one origin to destination. And then they have this big word of, but physicists, you can ask the question. I forgot a little bit, but they do study this problem. But what I think is missing is the behavioral aspect. And as an economist, I say you cannot study that if you don't introduce the concept of information. People are informed or not that there is a breakdown. After all, it's important. And then in terms of policy, what kind of policy do you have to inform people? Because again, as economists, it's not clear that you have to inform people. And if information is costly, maybe you have to choose to inform everybody, some people, and so on. So this is 1/3 of the paper, but the other 2 is not finished. So I say, okay, I hate static model. I really hate them, but I will use static model. Okay, because if I want to do 20 network, okay, a dynamic model, it will be 2-time consumer. And maybe to compare, static approach with dynamic approach will be interesting. Okay, so we find, forgot a reference in Nature where you can find all the data about 20 city, network, origin, destination matrix. Perfect, you just download the data. And now the problem is static network. We have an expert on static network, but it's that you don't know the path. You don't know the path. Okay, so we try to find a trick where you don't know the path that people are using. You know, you do an equilibrium that nobody can find another path and strictly minimize travel time. This we know. But if you take 2 routes in parallel, it's very easy to understand. Okay, which path are you using? I don't know. Okay, so the trick is to do that exercise without paths. Okay. Second, and we will propose a solution. The second thing is that, well, you want to know what happens when you have a small breakdown, a larger network, the big breakdown. But if you do like 10 simulation, you break partially one link and then 2 link. Break means reduce capacity. These are interrelated. And then how do you choose your path? So you cannot compare 1 link broken, 2 link broken. So we have a way to generate this catastrophe sequential. So there are 2 ways to affect a link. One is partial breakdown, so we reduce the capacity, and the other is the full breakdown. Okay, nobody goes. Okay, and what we do is that we, okay. I have co-author, Nicolas Geroliminis is the main co-author, EPFL. So what we do is that we have a law to generate breakdowns. And we say we could change, but we say it's not totally stochastic. It's proportionally to the flow on this link. So we run the basic model. So we have the flow, the static model, wardrobe business. And then we generate one link, probabilistically. We keep this link, we generate a second link, probabilistic as a third, and so on, and we go on the way around. Not in the end, but on the way around. And the same thing when you break, but when you break, the problem is that people who are not informed, you have to say something. So if you have partial breakdown, that's fine. You may have no information. That is, I don't know there is a breakdown. So I use whatever my root, you don't have to say which one. And then when I arrive, I say, oh, too bad the travel time is smaller, fine. I still go because I have no information, arrive to the destination as the same route. Okay? The people who are informed, but if you have a full breakdown, when you arrive there, no way you cannot go. So when we do full breakdown, zero information, you know at least the link which are broken. But beside that, okay, you do as business as usual. Okay, and so when you have, so we do full information, that's easy. The morning you know what are the breakdown, you recompute an equilibrium. No information, that's easy. You do as usual. And then to simulate it's very easy because you know the flow, you know how the capacity change, so you know how it affects travel time. So that's easy. And zero information and full breakdown, we know only the link which are broken. Okay, so what do we do? And now another thing is that you are interested in what, in a sense? Okay, so well, we came up with some statistic, maybe are not the best of the world, but we say, okay, the travel time is an interesting statistic. Congested travel time, that's one thing, which is by OD, you can do whatever you want, or the total one, and the speed is another statistic, and the vehicle kilometer. Because you do change your route, the people are informed. So in a sense, I should say that when you have mixed information, a fraction are informed, the fraction are not informed, the way it does, the trick, the modeling trick, is that the people who are non-informed as usual. The people who are informed is like stacker, it's a big word to say nothing, but they know, and they know that the other don't know. And we use the same route. And based on this information, they select their route optimally. Okay, this is the way it works. Now, unexpectedly, of course, the travel time decrease when you break down, and zero information is worse than full information. Now, you can construct theoretically what you want. I can say breakdown is good. Why? We know, Brass paradox. You break a link and it's good. So theoretically, you can do whatever you want, but we think it's not interesting, just little game. Let's see in real network. So we have Seattle, Minneapolis, Houston, and blah, blah, blah. Okay, we have this 10 different networks. We focus on Minneapolis and then we compare. Now, mixed information, this is more interesting because it's not, so a fraction are informed, a fraction are not informed. And the question, do you have to inform everybody? Not really. So in a sense that there is an optimum number. That's the model. You may say, I don't agree, but okay, the model say there is an optimum number of people who should be informed, but after deteriorate. If you inform everybody, you create a big mass and so on. And as an economist, you are not surprised because there is congestion. Congestion is not price. You're in the second best word. If you improve one instrument, nobody knows it will be better off. Okay. So now in terms of vehicle kilometer, we are not, okay, we did one simulation for one city, or one simulation, it means one link to link, 5,000 link broken. At the beginning, as expected, if you do breakdown, vehicle kilometer increase because you say, I cannot use my usual, I take another one. But then it decrease because some people cannot go to their destination. You are very happy, and then you can take the shortest path route that you were not taking initially because there are much less people on the system. And of course, there is evaluation we have not done because of the people who cannot arrive at this. It's a little bit arbitrary. I say, okay, you put what you want. If I want to work, I say, oh, it's a catastrophe. I cannot work. If you go to leisure, you say, after all, I don't care. I cannot travel. I go on internet and I buy my stuff. And there is classification of cities, and the worst one, that is the one where the resilience is the worst among the 10 cities, is Seattle. We have not understood why. So because, and what remains to be done is really to say, okay, 5 minutes? No, but I am done. Okay, 3 minutes. Okay. So what should be done is that can you identify ex ante parameter of the system which measure the resilience to shock? Okay, that would be useful. Why it is useful? Because if you say, okay, all these shocks are nothing, okay, forget. But if you think they are important, and if there is a war, it will be very important, by the way, then you want to construct, if you expand your network, a resilient network. So it can give you some guideline to say what kind, of course it costs, of course it's redundant, but it's more resilient, so we can provide guideline to do that. I am done.
Thank you very much. So we have time for some questions. Yes, please.
Yeah, thanks, Andre, for the talk. About halfway through, you said that in the case of full information, you can recompute an equilibrium. And I think that's straightforward, but is it realistic to assume that the users will adopt that equilibrium, right? Because it may be rare circumstances. So unlike with a tâtonnement process, right, they may just not know what other people will do, so they don't know what's best for themselves.
Well, I have no answer, but the way I would do it, if it is rare, is that there are informed people, maybe, I don't want to do that, of course, but there is an information system expensive, and then you get the morning, and I know I have to pay that, and the other, okay, say it happened once per month, and goodbye, I don't use it. But of course, what should be done, but later, is to do it with a dynamic model, because I have only one margin. I don't travel, I change my route. But then you may change your departure time, so you can be more subtle in adaptation, in a sense, to shocks. But that will be for you, Carlo. Next. Put noise in your network and see what happens.
Okay, maybe we...
No, you have to use the microphone number 1, not microphone number 2.
Is there a preprint available
The
of
what?
the work? Is there already a paper, or is it a work in progress?
No, there is a PowerPoint. There is no paper, but I completed the survey, and I say in the survey yesterday night after 2 glasses of wine that the paper will finish within 3 months.
Very good.
Thank you.
Okay, since the next paper that is going to be presented by myself in a minute is mainly dealing with the same subject. If there is any additional question, maybe we could postpone them to the end of the session. Now I'm transforming myself from chairman to a speaker. Coppola. So in the meantime, I can present myself. I'm Pierluigi Coppola, and it's my pleasure to be here. I'm from Politecnico di Milano, where I teach transportation planning, but I've been professor at Tor Vergata University for about 20 years. So it's my pleasure to be in Villa Mondragone. Thanks for the invitation and for having organized this conference here. So the paper that I'm presenting today is a piece of research quoted by one of my PhD students, Francesco Guglielmi, about the vulnerability assessment of transportation network under extreme weather event. And the presentation is structured mainly in 3 parts. In the first part, I'm going to give a little bit of a context, my view about resilience and the vulnerability of networks, of transportation network. Then I will present a methodological framework for assessing vulnerability. And finally, I will present a case study with some conclusion. So about resilience and vulnerability. I'd like to give a little bit of context in that respect, because often the two concepts are confused. In the literature, resilience can be defined as the intrinsic ability of a system to adjust its functioning prior, so ex ante, during and after a disruption, so a shock, that can reduce the performances, as Andres showed before. So, for example, reduce the capacity of some link, but also can completely block the some part of the system. And this could be due to expected or unexpected event. So basically the effect of this shock, of this disruptive event, is that of a decreasing of the performance of the network. And this loss, this performance loss, actually is the vulnerability. Basically, in fact, the vulnerability could be seen as the dual concept of robustness, where robustness is what actually is the spare capacity or the spare level of service of the system. But resilience is not all just about vulnerability or robustness. Resilience is also linked to another important concept, that is the rapidity to recovery. So basically, vulnerability is one of the two components of the resilience. That is a more broader concept. And this is important because basically the policy that we could put in place to increase resilience actually can be grouped into mitigation policy, that are the policy that actually here help to increase robustness or decrease the vulnerability. Okay, or adaptation policy, that are policy that aim at improving the recovery phase, so reducing the time to recover the lap. And vulnerability assessment typically support decision maker, administration, in defining mainly ex-ante mitigation policy, identifying, for example, the element of the system that has the highest priority in order to minimize the impact of the disruption or to reduce the impact. There are several kinds of vulnerability. Typically, engineers deals with infrastructure vulnerability, physical vulnerability that are basically the, let's say, capacity of an infrastructure to withstand to a shock, for example, a seismic vulnerability or the vulnerability with respect to landsliding. But as transportation engineers are more, let's say, dealing with functional and systemic vulnerability. The difference is that functional vulnerability look at how a system is able to withstand towards reduction of capacity or of level of service, just focusing on the supply side. So what is, for example, the reduction in terms of capacity or the number of available parts? Whereas systemic vulnerability take into effect also the effect that this disruption, so this reduction of capacity, for example, may have on the demand. For example, in terms of path diversion, as it has been shown in this very unfamous case in Italy, in which actually the national highways were breaking in two. And so people moving from the north to the south, in some cases, had to divert on the other coast, on the Adriatic coast, to reach their destination. But in principle, could affect all the dimension, also the mode choice or other travel dimension. Finally, and this is just to, let's say, position this piece of research, there are possible cases of disruption, so-called hazard. These are accidental or in some cases intentional, think for example to a cyber attack, and they could be internal when the disruption is belongs to the system, for example a catenary that break down or the railway tracks that they get deformated, or external due to some external event like an extreme climate event such as a flooding, a pandemic. In this table here, you see all the hazard, the possible hazard and the consequences, how they have been classified by a regulation of the European Commission. That is the regulation that now impose analysis such as the one that Dr. Blondel has presented, that are called climate proofing analysis of transport infrastructure, that now at European level are compulsory if you ask for funding infrastructure, if you ask European fund, CEF for example, or fund from the Commission to build infrastructure in your country. So this research focus on one specific accidental external event, that climate event, that are floods. And in fact, this problem, especially in urban areas, is becoming more and more urgent and more severe due to the increasing number of heavy rain phenomena that create floods. And in fact, the International Transport Forum, ETF, has identified floods as the most recurrent and disruptive hazard capable of generating system-wide impact. That means that this impact extends beyond the place, the nodes, the link where it happens, but extend to all the network. And these hazards are particularly relevant in the case of urban environment, since the extensive paved surface and the density, as you can see in the picture, exacerbated the impact in the EV way. The example that also represents the case studies in the third part of this presentation is the Milan metropolitan area. Milan is in a way similar to Venice, full of canal that now has been covered. And there are also two rivers, the Seveso River and the Lambro River, that have not been covered as the Navigli, that recently has become very frequently to see flooded. In particular, you see here some statistic. The Seveso River floods are about about 120 from 1976 to 2023, and a few months ago there was another huge one. So these recurrent these floods that create traffic disruption needs a vulnerability assessment. And this is the main motivation for this research. Now, the vulnerability assessment in this research is not just a theoretical scope, but the idea here is to develop a transferable methodology in order to identify those links that we consider critical links, so those links that need to be prioritized if you want to implement, if the administration want to implement a mitigation policy. So which are the first link that need attention, and what kind of mitigation measure is the most suitable. This is the schematic representation of the proposed methodology. Actually, you can see that it consists of three main steps. The first step is the identification of the scenario. The scenario is characterized by an intensity of the disruption, meaning how is the height of the rains in terms of millimeters, what is the extension of the flooded area, and also what is the probability that this event, the combination of intensity and extension, may happen. Then there is a second step in which, by means of traffic assignment, I recognize that static traffic assignment in this respect are limited, is one limitation, but of course this is one aspect that could be improved. Just a parenthesis for what concerns the information, when there are these very extreme events, you can be sure that all the people are informed, because there is a huge broadcasting through all the broadcasting channel. People are informed about which are the roads that are flooded, where the speed is limited, which are the roads that are closed. So in a way, if we assume that all the travelers are informed about the network and all knows the network, the user equilibrium could be almost accurate in terms of traffic flow forecasting. Anyway, in the second step, as you can see, many scenarios are simulated or can be simulated, each with each probability of happening that is linked to the time of return of that specific event. Then you can, using this, the probability of disruption with some KPI that have been introduced to assess the scenario, local and globally, you can identify the critical road links that are those links that are directly affected by the disruption, so the one that get flooded, and those that, on the other hand, should be prioritized in terms of mitigation actions. Those links that need attention, that could be the one flooded, but also other strategic link in the network, for example, link where all the traffic get diverted, that may need an increase of capacity. So let's go through each step very briefly, and then I will focus on the result of this analysis. So the first step is the scenario identification. As said, the scenario identification combines two factors. That is the spatial extension of the floodings and the flood water depth. That is, of course, the more the water depth, I mean, the level of waters that stay on the roads and that reduce the speed on the roads, right? And the spatial extension. Of course, the more the spatial extension and the water depth, the more is the severity of the scenario, but the less is the likelihood that it happens, meaning that this scenario has a higher time of retard. This is an example of 5 possible scenarios. In terms of extension, you see the extension of the flooded area with the relative return period. RP stands for return period. And of course, as you can see, the more the area is extended, the less the scenario is frequent or is likely to happen, as well as here you see which are the possible combination with, for example, different level of water depth. 50 millimeters, 150 millimeters, 300 millimeters of water. Then in the second step, for each scenario that combines the two effect, we have a transportation system models that simulate the morning peak hour. Typically, in the morning peak hour, this phenomenon happens and gives the worst performance. Yes, the degraded network performance here are computed. So the effect of a floods here is not computed in terms of capacity, but in terms of speed, of maximum speed that you can have on a given link. And as you can see, using these studies by Pregnolato and Ali, we have computed we have associated the water depth, so 50, 100, to a decreasing speed. And then using that speed in a link cost function, for example, a BPR, we have indirectly also computed the capacity of that link. For what concerns the demand, the analysis of the vulnerability has also split and segmented according to macro origin destination. Why this is relevant? Because in terms of adaptation measure, you can, during the floods, for example, divert traffic within the city, but also you can act and implement adaptation measure for city users, so for traffic flow coming from the external areas of the city, or in some cases, the flood could affect the travels that cross the city. So basically, we have a study area in the case of Milan consisting of 639 zones for which the Agency of Mobility provides DoD matrices for several purposes. And using these matrices, we have aggregated the DoD in inner ring trips that are the area within the rings of tangentiali that are this part here. Then external, internal, and then crossing or external trips. So basically, we perform a stochastic user assignment user equilibrium assignment model to compute the flow on the network under, let's say, normal condition, so base scenario, and in different scenario characterized by different intensity and different water depth. And the two indicators, the two transportation indicators that we have introduced in this framework are an indicator representing the impact at the local level, that is the volume capacity ratio, so the difference between a scenario K and the base scenario, and an indicator that takes into account the impact on the overall network in terms not of distance, but in terms of overall total travel time. So the vehicle hour here, and again, here we have the difference of the vehicle hour for scenario K with respect to the base here. Yes. This is an example for one scenario that we have simulated. The variation in terms where we have the highest variation in terms of volume capacity ratio on the network. And you can see that there are some, of course, these variation take into account also the path diversion of some flow. So for example, you see that here on this, on this highway, very sorry. Okay. On this highway here, you see an improvement, but because the traffic actually disappeared, because you have a problem exactly here. So basically you see that the traffic divert on this local road, and here is where you have the most localized effect in terms of congestion. You can compute also the overall total variation of the travel time that is plus 74%. This is one of the most extreme scenario that is here reported for, you see, just for as a benchmark. Then using these two scenarios, we compute a composite indicators that mix up the two local and global indicator and introduce also the probability that that scenario happen in order to have one single compound indicators that allow us to identify the most vulnerable links that, as you can see, are concentrated along the ring road and the radial access corridor, where actually you have a combination of the highest concentration of volume in the seat of traffic, of inner traffic, of inner OD demand, and of external, internal OD flows. For example, these are the top critical links affected by internal demand, and actually you can see why, because actually the Seveso here close completely one of the major corridor for entering the city. That is also one of the corridor in which in the peak hour you have very high volume of traffic. This traffic is diverted along this local road that, of course, cannot sustain it, and so congestion is generated. Similar consideration can be made for internal, external demand segment. This is the junction of the highway, Bemi, which you see connect to the city all the external traffic coming from Brescia, from Bergamo, and so on. And yes, the problem here is that some exit of this junction are stuck. And for what concerns the external demand segment, the criticalities arises on the local path when the A4, that is one of the most the most important highway at national level. We have 100,000, more than 100,000 vehicles, average traffic vehicles per day. When this is affected by the floods, so the capacity is reduced, because as you can see, there is a diversion also here on local road. So in conclusion, the proposed framework that combine local and effect with system-wide traffic rerouting in multiple flood scenario gives a systemic and transferable approach to identify what are the most vulnerable link under flood condition. And this methodology allow also to account consideration that are specific for origin destination flow. The methodology, of course, has some limitation related to the fact that we are here computing the indicators using a static assignment, whereas a dynamic, within the dynamic approach would have been more appropriate, maybe. This is maybe a research for the future. But the methodology as it is can support and has been used for the implementation of mitigation and also adaptation policy under floods event, in particular to identify which are those links in the network, as I showed, that need to be monitored before and during the flood event, and whose robustness should be improved, either with infrastructure intervention or through mitigation measures that affect the optional path, the alternative path along the connection. Moreover, the methodology can also be used to prioritize intervention in terms of road capacity enhancement, drainage system of works, floods, barriers, and so on and so forth. Thanks for the attention, and happy to answer to some questions. Thank you. Please.
Thank you. I want just to comment, because we are conducting similar, treating similar problem for City of Montreal in Quebec with colleagues there. And since we did not have access to an OD matrix, they did not get the OD matrix, we used the centrality measure for the network. So it was a little bit elaborate because the network is huge. But we ended up with similar conclusion that we should focus the effort on the main access and so on. But as far as I remember, we have one of the things that we have to take care about is the elevation of the roads, because in many times the bridges are concerned, and it is not enough to say, okay, you have this link within the flooded area. Sometimes it is a bridge and you have just to protect it. It doesn't mean it is flooded. So I don't know if you have...
Yes, thanks for the question. It is very appropriate and relevant. In fact, we did take into consideration this is a sort of a micro analysis of the network. And actually, just for elaborating a little bit, there are section, or in particular when you have urban highways that are not at the ground level, but as a bridge, and so they are not affected, but in some cases the junction that link to the ground level are. So basically in the identification and in the assignment, you may take into consideration also of this kind of effect by distinguishing not just in terms of spatial location of the link, but also in terms of whether the link is at the ground level or is over the ground level because it is in a viaduct. Thank you. Andre?
I was wondering a few things. Thank you for the talk. We will have time to discuss, but the first, I suspect you did stochastic user equilibrium and deterministic user equilibrium. So what more do you have or less when you use SUE rather than DUE? That's my first question. The second, I could not understand your resilience formula, square root of blah, blah to the square plus blah, blah to the square. And I was wondering also, you had elastic demand or an inelastic demand in your business? And last question is, if you want to find the hotspot, if I can say, it looks a nasty combinatorial problem. So I don't know if you went in this kind of, what are the things you want to avoid? And the last is not a question, is a comment, but I was thinking that once this type of analysis is done, you may jump and say, okay, what about the emergency? If you have really something big, emergencies that where people have to go, where do you locate the shelter and this kind of business?
Okay.
Thank you.
In order. Deterministic user equilibrium and stochastic user equilibrium on this type of network are not so relevant. I prefer stochastic user equilibrium because in my view, they include also deterministic user equilibrium and of course allow to overcome the problem that you have identified when you have links that are to the limit equal in terms of cost, no? But this is, I think, not relevant, not very relevant when you have this, realistic network. The second point was related to elastic demand. No, but in principle it is possible because, of course, you can simulate by computing the variation of the generalized travel cost with the trip frequency model. You can simulate the impact also on the demand volume. So in principle, the methodology could be extended. The question of the emergency, and I think you mean using the result of this simulation, you can then identify emergency corridor for emergency vehicles. Yes, this is actually one of the possible outcomes.
You have a big set of drones. Well, anyway, you have a nuclear central which explodes, whatever. Do you think that this kind of approach can say something?
I think so. Can help and can support the decision maker to, let's say, create and invest in some corridor that should be, let's say, climate proof or flood proof, let's say, so that are robust enough to withstand also with this kind of extreme event. So in that respect, it could give, it is an additional criteria for supporting decision makers. For what concerns the composite indicators, it is just a way, maybe the most easy way to combine the two indicators, the local one and the global one, just summing up them and weighted. Well, the square is just to, yeah, but is also that one could be food for who, well, could be food for future research in terms of sensitivities. No, by modifying that formula, you can see whether the results are sensitive to these the formula, the formulation of the indicator, the specification of the indicators or not. There is the
Thank you for your presentation. It's very good to consider the water level and the speed. It's very detailed. So my question is it possible to predict the variation with in the peak hour, the water level? Because if half hour may be quite different. So now it's 30 kilo, then you can be 50 kilos.
well, if but you have to modify, I guess you mean if you can also simulate the evolution of the water level in time. I think it is possible because there are models to simulate how, depending also on the intensity of rain, the water depth could be, let's say, evacuated. But I think that in that case, you have to reformulate all the simulation part in a dynamic framework. Okay. Another question?
Not done to clean all this business, take out my joke, that's a lot of work, and then publish on post it on YouTube.
Thank you. So now I think the session is closed. So Andre, I pass the floor over to you, or what's the? Okay. Thank you. Thank you, everyone.